Okay, saya start. Okay, Assalamualaikum and very good morning. Okay, so I'm Shakira. This is our third topic on multiple logistic regression. Okay, I think all of you are familiar with this logistic regression. Okay, just brief je lah. Logistic is actually part of generalized linear model. This is a predictive model. Okay. In my workplace, logistic regression is a very common and very popular lah, because we mainly work with data in binary outcome. Okay, NHMS, we deal with the disease like hypertension, yes or no, diabetic, yes or no, obesity, non-obese, smoker, non-smoker. So we use this logistic regression for predictive model lah. Alright. Today, this is my outline lah. Hopefully, I will cover. Actually, my lecture almost 50% on concept and theory, and another half on analysis lah using art. Okay. Previously, when I teach or give a lecture on logistic regression, I just give very light introduction on concept or theory, and then straightforward to step for analysis. But today, I also want to discover more what happened behind logistic regression. So just to compare the logistic versus linear. Okay, how we transform the logistic from linear, and then why logistic we call logistic use maximum likelihood to get the best fit line, and then what is coefficient, how we get the odd ratio from coefficient. After that, we go to art for analysis. Okay, so for introduction, logistic regression is a statistical method, actually similar with linear regression, because logistic also find the equation to predict the outcome. But the difference is logistic regression must be in binary outcome, in categorical and into group. Okay, for example, for binary outcome is success or failure, yes or no, this analysis. Okay, and for predictor factor or X variable, it can be either in categorical or continuous, either in one or more than one factor lah. Okay, so it's same with the linear regression. The difference is the outcome must be in binary. Okay, just overview what is the difference between simple logistic regression and multiple logistic regression. Okay, so simple logistic is a univariable analysis or crude analysis. We analyze one by one, the one factor together with their outcome, and because this is important now, because we want to find the important variable before we proceed to multivariable analysis. For example, we run smoking as a independent variable and heart disease for our outcome. And then we run separately, let's say gender and heart disease, for example. So that's why we call crude analysis. Right? So for multiple logistic regression is this is a multivariable analysis. We run more than one predictor at the same time lah for the outcome. For example, we run together smoking, low cholesterol, family history, hypertension, diabetic, and age. Age can be in continuous variable, and run together with heart disease. So this called multiple logistic regression or multivariable analysis. Okay, Before I go further, I just want to recall back the basic linear regression. Okay, because after this, I will compare the logistic and linear. Let's say we have a data, two variable. For y-axis is a size and x-axis is weight. Let's say we want to know, we want to predict the size of mouse based on their weight. And then we have mice, and then we just plot the case uh, based on their weight and size. After that, we draw the line. Let's say this is the best fit line for regression. Later, I will tell you how we get the best fit line for regression and for logistic. So, when we have the regression line, we can do a lot of things from this line. So, one of thing we can do is do the prediction. We can create the linear equation like this. I think all of you are very familiar with this equation. Y equal to A plus B X. Okay, A is a y-intercept and B is a slope for this line. So we can do the prediction even we don't have the data, so we can predict the any size, any weight. Okay, for example, this is the regression line. The slope is 0.78 and y-intercept is 0.2. So let's say we want to know the size of this weight is let's say 2.5. So we just plug in the equation and we get the size 2.15. Okay. So we also can add more than one variable. Okay, for example, to predict size based on weight and blood volume. Okay, for example. So this is a more complicated model lah. Okay, so now let's talk about logistic regression. You can see here the difference between linear and logistic regression. Let's say the size of the outcome, we group the size into obvious and non-obvious. So the logistic regression, uh, we just code as a 0 to 1. Okay, we predict something like true or false, probability to be obvious and non-obvious like this. So we cannot draw the line like linear regression. So this a this a main the difference lah between logistic and linear regression. On the my right side is linear and this logistic. So how we fit the line? Later I will share. So for logistic, uh, we get this like S-shaped line, or we can call the swiggle line or sigmoid line. Okay. So before I explain how we get the best fit line for logistic, first we look at the linear regression line. How we get the best fit line for linear and why they call linear use the least square line. Okay, so let's say this is a candidate for the fit line. Then first we need to calculate the residual. Residual is a difference between the observed data and the line. So we calculate all the residual with sum square of the residual and with square of the residual and we sum the residual. And then this sum square of residual, we compare with different line. And then we select the minimum or the least square residual. This is the best fit line for the linear. However, in logistic regression, we does not have the same concept with the linear. We cannot measure the residual, and then from residual, for linear we can calculate the R square, and when we can calculate the p-value for R square. But For logistic, we can't do because their outcome is measured by probability, right? So instead of using the square method, we use the maximum likelihood. Okay. So um, let's say this is our best fit line for the logistic. Using this line, we also can predict the outcome. Either can be probability of being this group or this group. Okay. So let's say we want to predict the probability of either mouse is being obese or non-obese. Let's say we have a new case with the heavy weight of the mouse, and then we draw uh, the, the 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 dot here, and we can estimate their probability. So there is high probability that the new mouse is being obese if dia punya Y is heavy. If dia punya Y is intermediate, so they have 50% chance that the mouse is being obese. Same thing if we have a very light weight of the mouse, so they have low or very small probability of being obese and high probability of being not obese. So from here we can classify this group. If there are the mouse, the probability is more than 50%, we can group this as a obese. All right. So our cutoff point is 0. The probability 0.5 and above. All right. From here, we also can do the equation like linear to predict the outcome based on their weight. For example, predict the obesity by weight. Okay. And then also we can add a few independent variables such as obesity predicted by weight, genotype, age, and so on. All right. So how we why we need to transform the probability to log odd? Why we need to log this odd? Okay. Um, so because linear regression, basically the value for y-axis is continuous. It can be any number, okay, from negative to positive infinity. But here for logistic regression, the y-axis is a range from 0 to 1. So we cannot get the intercept and the slope and cannot calculate the residual. Okay. So what we can do is we transform the probability graph into the light linear graph. Okay. So we just use the formula for odd, and why we need to log the odd later I will tell you, but for now the formula to transform from probability to new y-axis using log odd. Okay, this is formula for log odd. P divided by 1 minus P. This is actually a formula for odd. Okay, odd is a number of event can occur divided by number of event cannot occur. So P divided by 1 minus P, and then we log it. So we transform this probability to log odd. Okay. Let's say we select the midpoint of the probability, which is 0.5, and then plugging in this formula log p 1 minus p, and we get log 1. Log 1 is when we calculate using calculator, we get the 0 value. So we draw the new y-axis. This is our midline from 0.5 probability to 0 a new y-axis. So this is called our coefficient value. All right. And then we increase the probability to 0.731, and we get the new y-axis is log 2.717, which is 1. And then we calculate for the probability, increase probability to 8.8, we get the value of 2. And same thing, the probability of 0.95, we get the log of is 3. The coefficient is 3. And then the highest probability is 1. When we plug in the equation, we get the log 1 minus log 0. Any number that something that minus the log 0 is actually the negative infinity. Any number we minus the negative infinity, we get the positive infinity. So from here, we get our new line from 0.5 probability to 1. We get the 0 to positive infinity. And then we do the same thing with probability from 0.5 to 0, and we get the a new y-axis from 0 to negative infinity. So and up from this probability line, we transform using log odd, and we get a new y-axis from positive infinity to negative infinity. Okay, so here we can draw the regression line, light regression line, the candidate line, okay, to get the best fit line. For example, this is let's say this is the best fit line. So we get our y-intercept, which is negative 3.48. This is the coefficient value, and then the slope of the line is a 1.83. Okay, so this is example the output from R using logistic regression. So any software, when we run the logistic regression, they will give us the coefficient value. Actually, the coefficient value is a log odd. Okay, the transformation from probability to this new y-axis. And then we get the intercept, the coefficient for intercept, the log odd, and then the coefficient for slope. The coefficient for slope actually is a log, odd ratio, the difference of odd. So we can interpret with, for example, with increase with increase y unit of weight, will increase 1.83. Okay, so I just want to highlight that the value for coefficient actually is a log odd. Alright, so that's why we need to exponentiate the coefficient to get the original odd or odd ratio. Okay, so now I want to just brief explain how we get the best fit line using maximum likelihood. So previously we transformed y-axis from probability to log odd, and then we draw the best fitting line like this. The problem is, if you remember, for linear regression, we calculate the residual by estimate the difference between the observed value and the line. But for this new y-axis, we cannot calculate the residual because the 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 observed or our cases give the value of positive and negative infinity. So the residual is like the positive and negative infinity. So we can use the residual and can calculate the least square. And then how should we do is we use the maximum likelihood. Okay. So how to get the maximum likelihood, the best fit line? First, using this candidate line, we project our data, original data, to this line. Okay, like this. And then we transform back the log odd to the probability using this formula. P equal to exponential log odd divided by 1 plus exponential log odd. So how I get this? Actually, this odd reorder the equation. Later I will show you. So let's say here the first candidate is the first case is we push the first case into the line and we get the coefficient is negative 2.1, let's say. The second case is coefficient negative 1.4. And then we just plug in into the formula and we get our probability for each case. Okay. So the formula actually reorder the transformation from this original formula. So we pull out the P and we get this formula. This is just mathematical equation. From log odd, we get the P probability punya equation. Okay. Original from probability to log odd, and then we transform back log odd to probability. So we just, like I mentioned before, we just plugging for each observed value into this formula. Okay, and then let's say first case is negative 2.1, that we exponential it and we get the probability is 0.1. And then we do the same thing with the rest observed value. And then finally we will get this like a side mode shape or swigger shape line. Okay, after we calculate all the probabilities, so then we calculate the likelihood. And the likelihood actually will times all the individual cases and then get the value. But it's complicated, and usually they add the log for this likelihood because the value of log and the likelihood is not much different. And then when we add the log, just we from times we just do summation lah. So it's the same thing, just add the log and sum it all. From here we get the log likelihood value. Let's say this for this candidate line is a negative 3.77, and then we do the same thing. We draw the other candidate line and transform the log odd into the probability and calculate the likelihood value, and then we compare the value. After we get a few lines, finally we get the best or the maximum likelihood value. So this is the best line for logistic regression. Okay. Like I mentioned before, linear regression, we select the best line is using the least square line, but for logistic is using the maximum likelihood value. Alright. So same thing like I mentioned before. Let's say this is the best. Let's say this is the maximum likelihood, and this is the original candidate line. So we can create our equation using this line. Okay, the intercept, the y-intercept, and the slope. Okay, so now I just want to just give the concept how we get the coefficient. What's the meaning by coefficient? Okay, actually coefficient is from probability. Okay, and then when we interpret this coefficient for logistic regression is actually the value of this is a log odd. Okay. Okay, and then later I will show you how we get the odd ratio from this coefficient and why we need to log. Okay, here when we do the logistic regression, then we give the estimated coefficient and the standard error for estimated coefficient and z value. Actually, z value is a estimated coefficient divided by standard error. So we will get the z value. Z value is actually the word test. Alright. So when the z value is less than 2, the two standard deviation means the two standard deviation from our normal curve. then the p-value is not significant. So for example like this, the z value is 1.678, means dia punya a wave from 0 is 1.678, and then we get the non-significant p-value. Okay, so just want to brief show you what is the concept of odd. What is odd? How we get the odd from the probabilities. So everything from the probabilities for this logistic, and how we calculate the odd from probabilities. So let's say I have another example. We have four games, and then the chance or the probability of winning is one over the over the five games. So the probability of winning is 0.2. And then the probability of lose, the red one is 4 over 5, which is 0.8. Also, we can just minus 1 minus probability of winning, probability of event will occur. And then from here, we will get our odd ratio using this formula. Odd ratio is probability of event will occur divided by probability of event will not occur. For this example is the ratio of probability of winning over probability of lose. So 0.2, the probability of winning is 0.2 and probability of lose is 0.8. Alright, we get the odd is 0.25. So here just want to highlight that the odd is not probabilities, but we can calculate the odd from the probabilities. Also, we also can calculate odd from directly from their number of event or their count. For example, using the same example, the probability, the number of event will occur is one. Okay, winning the game, and then lose is four. We just divided 1 over 4. So also we get the same value for odd, which is 0.25. Same thing where either we use this probability punya formula or just use the count. So the transformation of from probability to odd is a monatomic transformation, meaning that the odd will increase as the probability is increased. Just want to highlight here, the value for probability is from 0 to 1, right? But for odd is from 0 to positive infinity. Okay, so you can see here, when our probability is almost 0, the odd is also almost 0. When our probability is half, means 0.5, the odd is 1. But when we increase our probability to 1, the odd is goes to positive infinity. So dia macam tak balance. Alright. So that's why we need to log this odd. Okay. So what is the odd ratio? The odd ratio actually just the ratio of odd. Okay. Or we can call the relative odd ratio. The relative odd. Okay. Odd ratio is relative odd. So odd ratio is usually we use to measure the association between group. Either use group exposure or outcome. For example, group male versus female, like this. So what I want to highlight here, how we interpret the odd ratio. Because when we do the logistic regression, finally we will interpret the odd ratio. So if the odd ratio is more than 1, this is a risk effect. If less than 1 is a protective effect. But if equal to 1 is no effect. Alright. So this is example how to calculate the odd ratio. Okay, the odd of one group divided by odd of the other group. Let's say this is exposure group and this is non-exposure group. And we get the odd ratio. If the odd ratio like this is less than 1, this is a protective effect. Okay, means that the exposure group is the exposure group is less likely lah compared to the non-exposure group. Okay, same like odd. The odd ratio also range from 0 to positive infinity. Okay, when we scale it, dia macam tak balance, not symmetrical. Okay, if our denominator is larger than numerator, so we will get the ratio from 0 to 1. If our numerator is larger than denominator, we get the value from 1 to positive infinity. Okay, that's why we need to log the odd to get the symmetrical scale. Okay, so because it's difficult to a model to estimate lah to calculate the restricted range like 0 to 1, 1 to positive infinity. Okay, so that's why we need to log this odd. Okay, so we transform the probability from 0 to 1 into the positive to negative infinity. Okay, using log. So here we can see the difference between odd and log odd. If we log the odd, we get the like a balance or symmetrical. Okay, so let's say the probability is 0.5, the log odd is 0. If the probability is almost 0, the log odd is negative 0.6, negative 6. Same is a probability is 0.9, 0.99, the log odd is 6.9. Okay, we get the like symmetrical punya scale. Okay, so that's why logistic we call the logic transformation. Okay, so because we transform the probability to log odd, so that's why we call the logistic is a logic transformation. This is the equation for logistic. Okay, actually this is log odd. So we go to analysis. Okay, for analysis, we use R software, but using the same step with other software. First, we start with simple logistic regression, and then go to multiple logistic regression. We do the variable selection to get our preliminary final model, and then we need to check our multicollinearity and interaction, check for model assessment, and finally we interpret our model. So you can refer to my art markdown punya note. Okay, so later I will open my art. So before that, for my example, I will use the file I name it as mi.sav. The original file for this data is from SPSS. Okay. Okay, so let's say we want to know the factor, to determine the factor associated with occurrence of MI. MI is myocardial infarction or heart disease. So we have a few independent variables. So our dependent variable is MI in dichotomous, yes, code as 1 and no code as 0. And independent variable is age in continuous data, and then gender, male and female, hypertension, yes or no. I code is all is yes and no. Yes is 1, no is 0. And then we have a smoking and obesity. So you boleh tengok tak? Hello, nampak tak Art?
Boleh.
Boleh Okay, nak besarkan lagi tak?
Saya okey je. Saya tak tahu
Okay
yang
Okay, clear?
Okay. Okay. So, sorry saya guna data from my data, tak jumpa yang open source punya data. Kenapa tiba-tiba macam ni pula? Okay. Okay. So, this is just a brief intro lah. Dah bagi tahu tadi logistik punya definition, and this is just brief our data. Okay, outcome is MI, and then kita ada 1, 2, 3, 4, 5 independent variable. Okay, ini I just nak clean my environment. Okay, I set my working directory. Okay, so read MI data, kalau untuk SPSS kita kena use download the library punya foreign punya package, and then I read my SPSS data. I name my new data is my data. Okay, so my data. Okay, just to check my data. So kalau tengok kat sini, kita boleh tengok semua macam dalam type, number punya type, kan, including MI. Actually from SPSS dia dah cantik dah. Bila baca kat sini dia jadi number. Okay, kita check lagi, kan, dalam bentuk 0 and 1. So yang ni lagi nampak lah. So dia dalam bentuk numbers. So first I need to change lah the numbers type to factor punya type. Okay. So I just buka, let's say gender as a factor, and then name balik lah dia punya code as male and female, and do the same with the rest variable lah, including MI. Okay, so kita dapatlah guna start punya function, dia dah jadi factor. Okay, so here we can see dia punya frequency for MI macam almost 50% lah MI case and non-MI. Okay, for gender pun macam balance. Alright. So age kita guna dalam bentuk continuous. So just go to our logistic regression. Like I mentioned before, we need to apa-apa multivariable analysis kita kena start dengan simple univariable analysis dulu. So we go one by one. Okay, let's say first the test antara age and MI. Okay, so this is the art function for logistic is GLM. Okay, so I name my model, this crude model is age_MI, and then GLM function, MI is a dependent variable and age is a my independent variable. So data is my data, and then for GLM we use family from binomial. So R we give a result for logistic lah. Because GLM kan dia banyak kan. So kita tarik formula untuk binomial. Okay, and summary. So ini adalah default dia lah. Output yang keluar untuk logistik. First dia keluar deviance residual. So saya tak cover pasal deviance tadi sebab dia panjang. But here we can see as long as dia center around 0, macam ni kita tengok kan. Dia not far from 0, so it's okay lah. So kita boleh check our model using deviance residual. So yang ni yang I nak highlight. Okay, the coefficient punya result. Okay, so actually like I mentioned before, coefficient is log odd. Okay, this is coefficient for intercept. the y-axis when kita punya x variable is 0, okay, the intercept. And then this is a coefficient for h, the slope, and the standard error, and z value and p value. So here kita boleh tengok kita dapat significant result for h. Okay. And then dia keluar juga null deviant and residual deviant and AIC. AIC kita boleh guna untuk compare dia punya model. Okay, tapi kalau tengok kat sini dia tak keluar teruslah odd ratio because it's difficult to interpret using coefficient. So kita kena dapatkan dia punya odd ratio. Just very simple punya function lah, code. Okay, kita just exponentiate the coefficient. Okay, so coefficient ni kita just exponentiate and then bawah dia adalah nak keluarkan dia punya 95% CI using config punya code lah. So kita dapat ini adalah odd ratio, and then this is a kita punya constant coefficient yang kita logkan dia, exponentiate the coefficient of intercept. Sorry. So and kita akan interpret using this odd ratio lah with dia punya 95% CI. So di sini kita boleh tengok dia significant using this odd test. Okay, significant, and then dia punya CI odd ratio with the CI, and kita boleh interpret macam contoh macam ni lah, with increase 1 year of age, the odd of having MI increased by 1.07. Okay, without adjusted with other variable. Okay, so this is crude analysis. So kita kena buat satu-satu lah untuk semua independent variable. Next adalah gender, just tukar je gen age kepada gender dan namakan dia as stack_mi, and then I straightforward use exponential to get dia punya odd ratio. And then okay, unfortunately dia tak significant for gender. Kita boleh tengok sini z value dia more than less than 2 and p value dia is not significant. So gender is a sorry. Okay, gender kita dapat result not significant. Okay, and then next hypertension and MI. Okay, kita dapat significant result. Okay, and then dia punya odd ratio adalah 2.6. Okay, 2.6. So we can interpret the odd of having MI among those with hypertension was 2.6 times compared to no hypertension. Okay, ataupun boleh interpret those with hypertension are estimated to be 2.6 times chance to get MI compared to those without hypertension. Okay, without control with other variable. And then next, smoking and MI. So dapat juga significant punya result, and dia punya odd ratio adalah 3.5. Okay, lagi tinggi daripada hypertension. Okay, so kita boleh interpret the odd of having MI among smoker was 3.5 compared to non-smoker. Okay, next, obesity. Okay, obesity also significant. Right, significant. And then dia punya odd ratio adalah 2.507. Okay, we can interpret the odd of having MI among obese person is 2.5 times compared to normal weight. Okay, so daripada 5 variable, only one variable not significant, which is gender. And then from here, we do the variable selection. Actually, untuk variable selection, kita boleh ambil the p value yang less than 0.25 from univariable analysis. Ataupun boleh masuk juga if we think that the variable is important, or we call the biological possibility. So we can add into the model. But from here, I just include all the independent variable, including gender, do the variable selection. Okay, for variable selection, actually they have a few methods using forward method, backward method and stepwise method. Alright, tapi actually saya tak jumpa dia punya code untuk buat backward forward. But apa yang saya buat adalah saya guna manual method macam backward method. Okay, backward method ni kita include all the variable into the model and then kita remove one by one yang not significant. Okay, contoh kat sini saya masukkan dulu semua including gender, sebab gender walaupun dia tak significant tapi dia less than 0.25. Okay, so dia punya art code dia adalah sama je, cuma kita tambahkan dia punya independent variable. Just tambah. The rest adalah sama. Okay, we see how the result kita dapat. Okay, semua variable significant except for gender. Okay, so apa yang saya buat, saya cuba buang gender daripada model. Okay, macam guna backward punya method lah. Okay, saya namakan IMI logic 2. Okay, my second model. So remove gender. Okay, tinggal age, hypertension, smoking and obesity. Okay, run. Kita dapat semua kita punya factor adalah significant. Okay, and then ini adalah odd ratio. And dia punya 95% CI. Okay, let's say this is kita panggil I decide to select this second model as a preliminary final model. Okay, model without gender. Okay, after we get the final model, kita kena check a few things. First, multicollinearity, and then interaction, and then model fitness. Okay, what is multicollinearity? Multicollinearity is a situation where our data contain highly correlated of predictor variable. Okay, antara independent variable dia highly correlated, so kita tak nak. Okay, so because multicollinearity is important issue in regression analysis, and kita perlu identify, and kalau dapat highly correlate either one variable, kita kena exclude lah, kena buang. So actually untuk multicollinearity kita boleh check guna correlation matrix, dia punya correlation antara each independent variable. Tapi untuk sini kita juga boleh guna VIF, variable inflection factor. Okay, untuk check kalau VIF ni less than 5 of 10, dia tak ada no issue on multicollinearity. Okay, because this code is very simple. I try juga cari untuk correlation matrix tapi tak jumpa dia punya code. I think using VIF also can lah, sebab dia lagi nampak kan. Kalau correlation matrix kita guna I punya ni lah, kita kena tengok satu-satu dia punya correlation less than 0.7. So yang ni kita just guna VIF. So VIF dia dalam package car. Okay, car package. Okay, so kita dapat kita punya VIF for each independent variable adalah macam one something, less than 5. So in our model there is no multicollinearity problem. Okay, next check interaction. Okay, interaction ni kita kena check sebab kita nak tahu either the predictor variable. Okay, interaction adalah relationship between one predictor variable and the outcome depend on the other value of independent variable. So dia akan kacau model. Kita kena check for each two-way interaction term untuk kita punya independent variable. For example, our final model ada 4 kan. So kita check all two-way interaction term. So kita ada 6 interaction term. So apa yang kita buat, kita masukkan each interaction term ni dalam kita punya final model, main effect model. And then kalau result dia not significant, so there's no interaction punya problem lah. Okay, saya just run je semua. Kita namakan model ni first untuk interaction antara H dengan hypertension is mi_inter1. Okay, so kita run dan kita akan dapat dia signifikan ke tak. Oh, sorry. Run je lah semua. Okay, yang first antara dia akan keluar macam ni lah, age and hypertension. So dia punya p-value adalah not significant. So okay lah untuk age dengan hypertension. Next adalah age dengan smoking. P-value dia also not significant, so no interaction. And then next age dengan obesity. So also not significant, 0.06. And then hypertension dengan smoking, also not significant. And then hypertension and obesity, not significant. And last is smoking and obesity, 0.511, also not significant. So we can conclude that in this model there is no interaction detected lah. Okay, so good lah. And then next we check our model fitness. Okay, so model fitness kita boleh check dengan a few tests lah. First using Hosmer-Lemshow test, and then classification table and AUC, area under the ROC curve. Okay, first Hosmer-Lemshow test ni adalah kita compare discrepancy antara expected probabilities, okay, yang kita calculate tu, and compare to observe the original punya ni probability. So kita nak dia punya null adalah no significant difference between expected and observed. So kalau dia not significant, dia maksudnya dia no different lah. So that's why kita nak p-value for Hosmer-Lemshow is not significant, more than 0.05. So untuk Hosmer-Lemshow kita kena install package resource selection. Okay, and then using this Hoslem.test. Okay, I create another variable for Hosmer-Lemshow, namakan mi_Hosmer, and then using our preliminary final model mi_logit2. Okay, and then keluarkan dia punya fit value. So, saya run. Kita dapat dia punya p-value adalah 0.4526. So okay lah, not significant. Okay, and then kita boleh check guna model fitness guna classification table. So classification table ni kalau boleh nak more than 80% or 70% pun dah okay. So overall percentage corrected. So maksudnya apa yang kita buat adalah kita macam cross-checkkan antara actual dengan predicted punya value, and then kita tengok how many percent dia corrected lah. Okay, so ini panjang sikit dia punya ni. Macam kita nak create dia punya probability and group untuk probability, and then kita tablekan dia. Okay, saya tunjuk je. Okay, first kita daripada original punya MI, kita tengok dia punya probability lah daripada yang final kita punya equation kan. So kita dapat MI punya probability, and then kita createkan group. Kalau dia less than 0.5, dia no MI lah untuk predicted. Okay, and then kita cross checkkan dia yang original punya MI dengan yang predicted punya MI. So yang kita nak tengok adalah kat sini. Maksudnya yang original MI adalah Yang ni, yang kita predict adalah yang ni. So overall corrected percentage adalah 829 ni divided by yang all yes MI. Yang ni, dia punya denom. So sebab saya tak jumpa dia punya code, I just manual calculate je lah. So 829 bahagi dengan dia punya denom yang yes MI, yang observe punya. So darab dengan 100, kita dapat classification table adalah 63.13%. Dia macam low sikit lah, less than 80%. It's okay, kita check dengan third punya method adalah guna area under the curve. Okay, area under the curve actually sama je, tapi kita guna dia punya continuous punya probability, and dia actually one sensitivity, one minus sensitivity lah area under the curve. And then kita calculate dia punya ni dia. So dia punya logic art code dia adalah LROC. So saya namakan dia punya ni adalah ROC underscore MI. And then kenapa tak dapat ni? Saya ada tulis. Ke kena ni dulu, install dulu.
Tak ada package tak install kot.
LROC malam lah saya dapat. Sorry?
Kena Google sekejap.
Kenapa dapat semalam? Okay, tak apa. I think tak lupa nak, mungkin ada nak kena cuba install dululah. Install package. Package kan? Install.
Package happy display tak?
Sorry?
Happy display kot package dia.
Tak dengar happy display?
Saya type.
Ni happy display
Happy display. Apa tak keluar? Ke library LROC ya? Pula. Okay, tak apa. Kita proceed je dulu. And mungkin ada package dia lah kot. And dia punya code dia adalah macam ni lah. LROC. And then untuk area under the curve, kita just tambah AUC je. So yang saya dah buat, actually saya dapat 75.89%. Okay, for AUC. Alright. So kalau kita tengok yang first Osman and Shaw adalah not significant, so okay. Classification table is less than 80%, dia macam low sikit.
But untuk AUC kita dapat 75.89%. Okay, actually dapat dia punya curve ni ni. Dapatlah dia punya apa? ROC curve, and then dia punya area under the curve adalah 0.758. Okay. So kita assume that our model is fit lah based on 2/3 criteria. Okay, so simple je. So bila dah check semua, kita akan dapat kita punya final model lah. Sebab dah banyak sangat, I just rename balik my final model jadi mi_final. Okay, opening. Okay, and then run je. Sebab kita nak dapatkan dia punya coefficient. Yang penting ada coefficient, ada p-value, and ada dia punya odds ratio with dia punya CI. Okay. Ini saya dah summary lah kalau nak tengok. Okay, dia punya macam mana nak dapatkan result dia lah. So, nanti kita akan interpret. Before this, I just want to share macam yang I mentioned before, kita tak boleh calculate the R square using logistic kan. Tapi guna package R ni, kita boleh dapatkan pseudo R square. Okay. Okay, dia punya ni panjang lah cerita yang ni. So boleh baca nanti. Kita still boleh dapatkan R square for logistic regression. Okay, kalau guna software lain macam SPSS memang tak keluar lah dia punya R square. Okay. So package ni ada daripada Zhang, the author of RSQ package. Okay, kita kena install RSQ package. And then dapat dia punya apa semua. Dia tengah run lagi. Lama pula internet kot. So yang saya dah run, kita dapat dia punya R square is about 20%. Okay. Okay, so kita dapat 0.201, macam about 20.17% lah. So kalau untuk regression, dia macam dia punya variance lah, macam contribution of factor tu kan. So macam kita punya factor yang 4 factor ni hanya contribute 20.17% lah into the model. The other 80% ni mungkin daripada faktor-faktor lain lah. Okay. So macam mana nak interpret? Okay. So kita tengok macam mana nak present dulu. So ni adalah cara untuk kita, contoh lah untuk kita present logistic regression. Okay. Mungkin kita boleh letak kat sebelah dia punya crude. Okay. Simple logistic and multiple logistic. Okay. Yang penting ada beta. This is a coefficient, beta coefficient. And then odds ratio, the exponential of the coefficient, dia punya CI and p-value. Kita tengok kat sini semua significant and dia punya odds ratio adalah more than 1, which is dia adalah risk lah. So kita boleh kata age, diabetic ni the type. Age, hypertension, smoking and obesity was significantly associated with occurrence of myocardial infection. Okay. And then kita boleh interpret satu-satu lah for each independent variable. Contohnya untuk age, with increase 1 year of age, a person has 1.05 times the ought to have MI after adjusted with other variable. Yang kita boleh support dengan kita punya CI and p-value. Kalau untuk categorical punya variable, kita boleh interpret those with hypertension contohnya has 2.84 times or odds of having MI compared to non-hypertension. Supported with this CI and p-value. Okay. So last saya just nak share yang menariknya untuk art ni, saya jumpa satu code untuk kita draw the probability punya graph. Okay, nanti I will share you the code. So daripada sini kita boleh tengok from our final model lah kan, kita buat prediction. So yang turquoise ni adalah yang dia punya original data dia adalah MI, and then no is no MI. Y axis is a predicted probability. So tengok sini yang ada MI dia punya probability is macam high probability lah daripada kita punya predicted. So mungkin boleh present lah this graph. Okay. So dia punya code dia adalah sini. Panjang sikit lah. Kita guna ggplot and then kena add dengan cow plot. Okay. Okay. So menarik. Sebab dalam benda lain takkan dapat kot draw graph macam ni. Okay, I think that's all from me. Ada apa-apa soalan?